Okay, we're here at the 3Dponics booth. They're one of our 3D exhibitors, and we're here to talk to them about their products that they've brought with them. So could you just explain to me what's going on here?
Well, this is our 3D printed hydroponic system using a couple 3D components and some recycled bottles you can see here. You can string together the few bottles in sequence. It makes for a very compact system and a drip-fed hydroponic system. So using a couple simple 3D printed parts that look like this one and like this one, they're printed with the threads just inside so that you can screw it right onto the end of your 2-liter bottles. And then they have holes in them so that you can tie them to the next one, and you can see it dripping through right here. And then this magic piece goes with our air pump. So it uses the ventrili effect and a regular marina air pump. So the same type that you put in your fish aquarium. And it shoots air down the 2 lines that go straight up, and it causes a vacuum in the 3rd line. So it sucks a few droplets of water up at a time. If you want to check over here, you can see it airlifts droplets of water up the line to the top of the system. Drip feeds the system, which drips down in sequence back down to the reservoir at the bottom. And it's pretty much very low maintenance, very compact, cheap and reusable hydroponic system. You only have to top it up every couple weeks and monitor the nutrient levels. Other than that, it's pretty awesome. It makes a great science project. Lots of schools are very interested in it right now because it helps incorporate 3D printing technology. So our wonderful 3D printer over here, you can see hard at work, making the components.
Could you explain to me what material you're printing in?
We're printing with Pla Plastic, so it looks like this when it's on a spool. And it's just a thermoplastic, the same type of thing that most 3D printers use. Some use an ABS, both are okay. Pla Plastic is, if you go back in the ingredients far enough, is actually corn-based, so it is biodegradable.
And it's safe. So
and it's safe for using with food and consumption, exactly.
You're going to use it in your home or in a school, it's a good thing to start with.
Most Pla Plastic is not GMO-free, but you can shell it a little extra to get GMO-free Pla Plastic if you're super into it like that. Some people are, they ask us, it's very specific. So other than that, once you have the basic system set up, there's all sorts of cool devices that you can print on your 3D printer to make life with your 3Dponics more fun and simpler. There's a drip system here for the roots if you want to put it in instead of dripping it down. A catcher for the medium here. I'd rather use the other one if that's okay.
Okay.
Just because I don't want to break this one, sorry.
Okay.
So this right here is the start of our fully automated system. So 3Dponics right now is open source and free. So you can go download the schematics for all these parts online for free and print them and do it yourself. Now what this little device is going to be in the future is a stackable, interchangeable thing. This is the battery on the bottom, a temperature sensor, and this is just your Wi-Fi connection for now. We're not fully finished developing the system yet, but the idea is that it's going to sit down on the side of your tank and monitor for you the temperature. It's going to monitor your nutrient levels, it's going to monitor your parts per million, and you'll be able to control all of these things from a smartphone app. And that's the goal. That's our end game. So,
would you then sell these modules? Is that
the idea? Yeah, the idea behind these modules is we're developing them for sale. Right now, like I said, the hydroponic system, because it's so awesome, because everyone loves it, because it's so educational, we have to give it away for free. All the components are free, right? So if you've got the 3D printer, if you've got someone with a 3D printer, you can definitely do it. I encourage you to do it because it's really fun. The school applications are endless. You're combining the 3D printing technology as well as all of the same plant sciences that you had to learn when you grew a bean in a cup. This is way cooler than a bean in a cup. You laugh, but it's true. We all did it, and this is way cooler than that.
How long does it take to print 3D parts? Is that something that you can do in a lesson time? Or?
Definitely not something you could do in the span of a regular lesson class.
Okay.
However, a lot of schools are pushing right now to get 3D printing labs and stuff. So, you know, if you set it to print and then the next day you came and it was done printing, you know, that'd be okay.
Yeah.
Most of the components don't take too long. If you were only printing the amount of nozzles and the fork to make the system 5 or 6 hours about.
Okay.
Some of the other components like this 3D printed sleeve here is very tall and takes a really long time to print. So it takes about 7 or 8 hours. That's what we have printing on the printer over there because it's slow and looks really cool for everyone.
So, okay, now we're moving on here.
Yeah. Do you actually have a second card?
Yeah, I do. I've got a bunch of them. Yeah, sure. And at any rate, we're accelerating.
And one of the best parts about the 3Dponics system in general is that it's made out of recycled parts. It's made out of 3D printed parts, which are also very cheap to manufacture, at least a few at a time. And it's also open source, so it's free, as well as it's very cost effective as far as money goes, because you're using recycled parts, and because we use an air pump specifically. Oh, we already went over that. I'm sorry, man. Because you're using an air pump, you never have to worry about the pump breaking down from pumping water. There's very few leak issues ever, as well as it only costs you about 3.2 cents a month, depending on where you live, to run the electricity for an air pump 24/7. You can't overwater the system because it drips through. You can't underwater it because it's always watering. You only have to fill up the reservoir every couple weeks, and you've got 4 full-grown yielding vegetable plants in the space that it takes to grow.
Do you have any idea how many of these systems actually exist in the world? Do you know how many people have actually built one?
Right now on 3dponics.com, that's our online community. That's one of the things that we're trying to build, because the more people, there's a ton of people that know about hydroponics and there's a ton of people that know about 3D printing. We have to put them together so that everyone can work on this. Like I said, it's the open source that makes the system possible. Every time someone has an improvement for the system, they put it on the website. Right now, I don't know how many actual systems there are, but I know the website has 1,200 members right now. I have personally seen pictures of at least 23 different systems. I have one in my house too, so.
What's next? What's your next development?
The next development, well, the 3Dponics system is constantly being developed because everyone's always making new parts and always changing it, right? So it's never really finished per se. There's always stuff that's going to change and improve. If you want to have a look here, you can even see the progression of the fork piece. So this was our original design, and we put a hole in it to try and improve its performance, which failed. So then we took the hole back out, and this one we developed a couple months ago does exactly the same job as the fork piece, but only needs half the amount of air. So we've increased our capacity by 50% by just changing a part, and it was someone else's idea that helped us do that, but in the end, no one's trying to be like, well, that's mine, and now you have to pay for it. So, but in the future, we're hoping that our software is developed really well, and that everyone can have a fully automated system and take care of their own vegetables and growing stuff all by themselves, right?
I guess the kind of big limitation of this is owning a 3D printer. Do you think the cost of owning a 3D printer is a problem for your end users?
Definitely it can be an issue, especially the newer ones are quite expensive, but there are a lot of very affordable 3D printers, and they do make a fun project themselves too. You can buy a kit to build your own 3D printer, but also one of the things we're doing on 3dponics.com is because we're making that community that's connecting people, and it has maps so that you can see the location of other people, the pictures of their systems. It will allow you to find maybe the school down the road from you, or maybe a neighbor like in a town 10 minutes away has a 3D printer, is on the website, and also owns one of these systems already. And that allows you to collaborate as a community instead of coming to us and being like, well, you're the manufacturer, send me parts. Because that's not where we're trying to make a community that can sustain itself in a way that everyone's helping everyone better everything.
A lot of people tell us that the reliability of their consumer 3D printer is not good enough to reliably print parts. Is this something that you suffer with?
As far as like large-scale manufacturing, like if I wanted to print these components all day, every day to mail them out to people, definitely there would be a lot of failures and headaches and clogged extruders. But with the newer printers, the technology with 3D printers is advancing very quickly in leaps and bounds. So every new printer that comes out is easier and easier to use and easier to maintenance. Definitely if you're building one or if you're just a tinkerer, you're going to have some issues with some lower quality prints, but that just comes back to the 3Dponics website where you can find someone who has the $3,000 printer or a school that will help you out, right? So definitely you could print some lower quality parts and they could still work, but the future is still coming at you, right?
Okay, well, thank you so much for your time. Thank you for talking to me.
No problem.